Practice Exam 2, Part 3. Okay, we are up to question 6. Prove the following theorem. Okay, so I'm going to say this very loudly for the lazy students who didn't watch Unit 9. Okay, you will be presented with questions like this in the exam, and this is how you will see it, right? Question 6. Prove the following theorem. Prove this following theorem, right? And look at that. You've just got a formula all by itself right after there. Okay? So you may very well be asked to prove a theorem as in here in the definitions and questions section, and I promise you that you will be asked to prove a theorem in the proofs section, and it will be worth 25 or 30 or 40 points. Okay? Many, many points. Which means if you do not know how to do the first and most important thing when asked to prove a theorem, you will get nowhere and you will not get any points at all. Okay, so what's the most important thing? It is, it's just, right, you're looking at a page, you just see a formula, right? What do I do with it? This is the most important thing. Put that formula at the bottom of the proof. At the bottom of the proof, not at the top. If you put it at the top and you treat it as if it's a premise, you have gone completely wrong and you will go nowhere. You are not given this formula. You are asked to prove this formula. Okay? What is a theorem? Theorems were discussed in the last section of Unit 9. Theorems are formulas which are proven with no premises, right? Theorems always start with an assumption, right? Because so they're proving, my kids know how to prove theorems, so you guys can do it too. Theorems are formulas which always begin with assumptions, right? They never start with premises. They are formulas proven with no premises, okay? They're always tautologies. So what the first thing to do, right? This is the most important thing, because if you do this and then you continue going about doing proofs like you normally do, you'll be fine, right? But if you don't do this, right? So you're asked to prove. Proof mean when the exam asks you to prove something, you have to supply a proof. Right? Don't go as I'm writing here. Okay. If you put the formula you're asked to prove, the theorem, at the top, where are you going? What are you doing? Right? You're saying, okay, I've got this, let me derive some things from this. Why are you deriving things from this? Right? You are tasked with proving this formula, this theorem. You don't put it, okay, you've got to cry outside. You're asked to prove it, okay? So you've got to put it down the bottom. You've got to justify this formula. Okay, this one is very easy if you first put it in the right place. It's just P hook P, wait, sorry. No, because you can't. No. Okay, that's the theorem, right? That's what you're asked to prove. This is the most important step, okay? Don't put it at the top, put it at the bottom, please, please. Okay, put it at the bottom, that's your formula, and now what do? Now it's just like any other proof, okay? And you proceed like any other proof. So you look at this formula, right? Of course, here especially you're going to remain conclusion driven, which is the advice I give in general for doing proofs. That is, look at the formula, ask what it is, what is its form or structure. It is a conditional, so you're going to set up a conditional proof. Okay. Theorems always begin with assumptions, and the only two ways of making assumptions are making an assumption for conditional proof or making an assumption for indirect proof, right? So if you're proving a theorem, you might be assuming a theorem, trying to derive a contradiction, so you can derive the negation, in which case your conclusion will be a negation. And for any theorem, as I've said in the lectures for Unit 9, which you have videos for whatever, say you're given any formula at all, you can if you're asked to prove it as a theorem, you could be working backwards, you could double negate that. This is now a negation, so this is now is now in the form for a conclusion for indirect proof. Remember, indirect proof, the form is you assume P, derive a contradiction, anything of the form Q or not Q, and then your conclusion on the main line is not P, right? The negation of the thing we assumed. Conditionals and conditional proof is different. And here, since this is a conditional, obviously conditional proof is the way to go, right? Is the right assumption to make. Well, conditional proof will be the rule I use to justify this, right? So we've got the main line. My first step is an assumption. I always indent when I'm making a subproof. You use subproofs for conditional proof and indirect proof, the rules for Unit 9. And it's easy as pie if you know how to do conditional proof, right? What do you do with conditional proof? You assume the antecedent, and as I stress in the lectures for Unit 9, conditional proof has the advantage over indirect proof in that if you set up for conditional proof properly, you know exactly where you're going. Because what do? You put the antecedent of the conditional you want to prove up the top. That's your assumption. My justification is assumption, ASSP, brackets, conditional proof, right? And, very crucially, you put the consequent of the conditional you want to prove at the bottom, P or Q, right? This consequent here. Because if you can, right, what is this formula? This formula states that if P is true, then either P or Q is true. If you process it for meaning, you should think, oh yeah, I should be able to prove that without any premises, because in all circumstances, right, in all possible worlds, if P is true, then either P or Q is true, right? So the structure of conditional proof sort of reflects that. It's just, I'm assuming P, I'm seeing if I can derive P or Q from P, and if in fact I can, I'm entitled to derive on my main line as an absolute truth that if P, then P or Q, right? So you just put the antecedent there, consequent there, okay? So you've got your assumption in place, and you should know how to get from P to P or Q. That's just addition, right? So 1, add, we didn't have to do anything else in between, right? But notice that went there, the P went here because that is the antecedent of the conditional I want to prove. The P or Q went here, not from seeing that I'm going to add something. This is P and Q here because it's the consequent of the conditional. I looked at that and I put that there, right? And then I asked the question, how do I get from here to there? Oh, I can just add straight away. I'm done. 1, add, right? So that's 1, step 2, step 3. Justification, step 3, conditional proof, 1 through 2. That's the proof, okay? What's the big lesson here? When you're asked to prove a theorem, put the formula at the bottom of the proof.